The title of this webinar is of cloud computing and power washers. Strange comparison between the two, but as you'll see, there are lessons to be learned between a common household item, a power washer, and the sophisticated world of cloud computing that ultimately will perhaps make your decisions easier. I'm going to start this presentation with my front walkway, which, as you can see, has a lot of slate. Slate is very nice, looks great. Problem is that every year it gets dirty. Come, I don't know, September, October, sometime in the fall, I think to myself, it's power washing day. So I go down to my local hardware rental store, and if you're wondering, yes, this really is my local hardware rental store, which I got off Google Earth, and I go rent a power washer. And I ask myself the same question every time. Should I have bought this thing? I rented for a weekend and it cost me $85 and some tax. I buy it, go to Sears or Home Depot, and it cost me $309. So I think to myself, wow, I could have bought it and after 4 uses, it would have paid for itself. Why do I keep on going to rent this thing? There are great reasons to buy. I could lend it to my neighbors, which is actually a very good reason because I borrow things from them all the time. I'll use the power washer more and clean more things. Long term, obviously, like I said, I'd save money. Then I think, where am I going to put it? I'll have to maintain it. It's more junk to have around the house. And of course, when I rent, they've got a really powerful power washer, probably more expensive than the one I could buy. It's not that big an expense in the scheme of things. I only need it once a year. And it's really heavy to carry back and forth. Oh, I'm sorry, that's a bad thing. So, you know, it's a complex decision-making process, even with my power washer. Well, every year I rent it. It's cheaper over a few years to buy, as I mentioned. There are some good reasons for doing so, and yet I still rent the power washer. If those of you are wondering, for those of you who are wondering, why do I have a power washer in a cloud? You just don't get the pun. It's cloud computing. Recently, we had a similar problem. We needed to replace a server at Galarath, so we compared the numbers. All right, so in-house. First of all, this is an important server. So the cost went beyond just the box. We needed extra storage and reliable backup. As you can see, the cost for that is all just about under $9,000. We figured the labor would be about the same, and our landlord pays our electricity, in addition to providing a hamburger truck every once in a while, but that didn't factor into the cost here. We looked at a cost of provisioning that server, equal computing capacity in the cloud, and as you can see from the snapshot, it costs about $535 per month. Okay, so keep that in mind. Almost $9,000 to buy, $535 a month to rent. So that stopped us in our tracks. It would cost us about $6,400 a year for a cloud solution if we want to use a server in the cloud to replace our current in-house server. That came to about $6,400 a year. Assuming the server needs to be replaced every 5 years, which is an industry standard, that cost would come to about $1,775, maintaining the server in-house. Of course, we don't have to pay real estate. We don't have to pay utility, and we're not assuming any labor because we figure the cost of administering the server is about comparable. So this is really just the material cost. Clearly, there's lots to learn. First off, even though I've shown you some awful cost comparisons between in-house and cloud just for a single server, I'm no naysayer about the cloud. On this screen are all the cloud computing services that I currently use. I run big databases and Ubuntu instances on AWS. I run test servers on Azure. I build iOS projects using Mac and cloud. and I run a WordPress site using 1.1. So I pay cloud computing bills all the time. I might add too many cloud computing bills. The key here is that we aren't talking about apps in the cloud, software as a service. For the rest of this presentation, let's make this clear. Cloud means either infrastructure or platform as a service. I've talked about the term, I've used the term cloud loosely, but we have to narrow this down. I hope this is, and I'm sure those of you who are listening to me are trying to read this cartoon here. The basic idea of the cartoon is you're dealing with apples and oranges. Software as a service, platform as a service, they're kind of similar. Infrastructure as a service, rather, you're dealing with different terms. I think I just messed it up myself. Let's clarify here. The big as a service categories are infrastructure as a service, platform as a service, and software as a service. We are not talking about stuff simply in the cloud in our presentation, which means software as a service. You may use Skype, Dropbox, mail, but those are still just applications. The cloud may have made them possible, and being cloud-based gives them unique advantages, but at the end of the day, software as a service are still just applications in the cloud. Our focus here is on utility computing. In other words, provisioning raw compute cycles. That certainly includes what is referred to as infrastructure as a service, but developers frequently rely on specific environments and frameworks, and so platform as a service is equally relevant. And below each, you can see examples of infrastructure as a service plays and platform as a service, and you'll notice that there is some bleed in offerings between them. For example, Amazon is starting to offer platform. MS Azure was originally really more platform, but then they are also very much infrastructure. So you see there's some bleed between what the various vendors provide. We're going to stick with infrastructure as a service and platform as a service, because software as a service, apps in the cloud, are really very specific judgments to be made based upon the applications. And this just emphasizes that we're focusing on what some people call utility computing. In other words, you purchase electricity to use it to turn on your machines. You purchase raw utility computing to run various sorts of apps, perhaps that you yourself are developing in the cloud. But you're basically running it as a utility that can run any sort of application. Let's start with what's a great cloud scenario. Just like the power washer that I need every year, it makes kind of more sense to rent it, I guess. And that's because the peaks are extreme. If I were to have to handle those peaks in-house, it'd get very expensive. I'll show you what I mean. A poor cloud scenario is where the peaks are very shallow. Building for peak usage is expensive, and this is true in a lot of areas. Utilities don't build for peak usage. They don't keep their plants on to handle peak usage. They start up plants when the peaks, the summer usage comes in. They'll start up their gas plants, whatever. Other sorts of utilities do the same thing. They don't run all their machinery for peak usage. They run it at a baseline represented by that gray area at the bottom. And the red area, you bring in the capacity as you need it. Another great cloud scenario where you are starting something out, maybe you're a startup, or maybe you're starting a new service and you're unsure what the usage will be. Maybe you're changing over a system and you're not sure yet what the computing capacity, the computing needs will be for that system. That's a scenario where you have very little knowledge of what the future brings, as the dashed line shows. And the gray areas show the amount of capacity dedicated to handling the usage need. And I intentionally undersized or oversized the boxes to show how you make mistakes when you don't really understand what you need. That's a great cloud scenario because you can actually dynamically schedule cloud computing resources or dynamically allocate, I should say, cloud computing resources to handle needs as they develop. A less great scenario is where you have pretty good knowledge of what you're doing, and so you just build for that, and you don't have much variability at all, as the bottom would show. A really sophisticated cloud scenario is where you can very granularly allocate resources to need. So I zoomed in basically on a slide I had on the previous one of the previous slides, and what I'm showing here is how even on an hourly basis you can spin up spot instances of computing to handle even diurnal daily rhythms in usage. And a lot of the major internet applications out there, internet services out there, are very much using this sort of pattern and allocating to this sort of pattern. Now, in the mortal words of Buckaroo Banzai, wherever you go, there you are. In other words, you can manage machine utilization poorly or well in the cloud or in-house. The difference is that if you don't manage capacity utilization well in the cloud, you may find yourself with a big bill at the end of the month. Because economies of scale do matter, many large enterprises are finding excellent efficiencies running private clouds. Typical server utilization is said to be at about 15 to 20% of capacity. So running your server in-house or running it in the cloud, you have to be aware of your server utilization regardless. Partially, this is because, especially in-house, servers are often sized for peak load. You don't want to run your server 100%, not even in a data center where you care about high utilization. It's also because people tend to buy more server than they need. When you go out and buy a server or a computer for your house, you're not buying for what you need today. You're buying it for what all the pictures and videos or applications or databases you're going to throw on later. So you're going to oversize. That oversizing when you're purchasing a computer makes economic sense, but it also costs more. And if you can just purchase your assets dynamically in the cloud, you're not forced to make an economic decision like that. You can actually purchase just what you need when you need it. So the cloud is preferred to the extent it lets you manage resources better. There's some other reasons, but that's a big, major advantage of the cloud. At the same time, and this is another aspect of managing server utilization, we see the software as a service, which we're not touching directly, but software as a service is taking huge bites out of the server. Outlook and other email offerings were an early major application to get pushed off the server. It simply works better in the cloud. Backup is more reliable and more secure in the cloud now. Storage, there are many hybrid scenarios offered by cloud providers where storage is handled in the cloud rather than off the server itself. CRM systems such as Salesforce and Sugar developed cloud applications very early. And of course, help desk. So there's a declining need for servers in-house, even if we're talking about infrastructure and platform as a service. The software as a service developments are really negating the need for local servers anyway. And even in the large scale in data centers, you're going to be moving a lot of that capacity elsewhere just by virtue of the fact of cloud apps. Now let's go beyond cost. This is me having a conversation with the power washer dealer. We're just talking about renting versus buying. I go to his store. He says, "Well, yeah, do you have 2,000 psi, the one you can buy? Does it have as long a hose, all the nozzle adjustments? Oh my God, I think there's way more to this thing cost." This is the Amazon Web Services, AWS screen. You look at all the options you've got here. You can do stuff with AWS and other cloud providers that's very hard to do on your own. For example, you could do content delivery networks to push stuff to your users without clogging up bandwidth. You have a lot of different data management solutions. You have very good analytics. You have things that are specialized towards mobile app deployment. Tons and tons of things that you can tie in that would be very expensive to do in-house. You'd have to build out networks and build out equipment. And so even if you're comparing the apples to apples, compute capacity in the cloud versus local, it's the other stuff that may even sway you to going towards AWS or Azure or Terramark, because they've got the infrastructure stuff down cold, the stuff that really ends up costing money and taking time to do. So it's not always just a cost decision. Uptime is another important consideration. Let's say your uptime is 99.6% in the office. It's really good, isn't it, right? Well, Office 365, apparently, this is one example that I took, is 99.9%. What does that equal? That equals a day. So do you want to have your email out for a day every year? The difference even at 3 sigma is very important. It equals days of time or hours of time. Do you want to have a critical app offline for hours, the system offline for hours? So it matters. With multi-zone availability, you can actually increase uptime even further with not just the software that Microsoft is offering to users, but also your own. You can attain similar uptimes. Sometimes the monthly plan is simply easier to stomach rather than a big capital outlay, especially startups, other early stage companies, or maybe programs being launched by large enterprises where hardware is not immediately available. The pay-as-you-go plan often is very helpful. So there's a lot of reasons beyond cost, obviously. Cloud computing versus in-house computing kind of looks like this. It's a mix. If you look at the major cloud providers now, the term hybrid keeps on popping up. What does hybrid mean? Hybrid means that you're doing some of the stuff in the cloud, doing some of the stuff locally. And it seems like that's pretty much the way things are settling out. People are choosing to do their mission-critical apps, their maybe SAP, things like that, things that are highly integrated into their operations. They're doing those locally. They're doing their specialized things, high-speed trading, things like that, which really require specialized hardware and networks. They'll do that locally. They'll handle other things like analytics, batch analytics in the cloud. This slide kind of shows the lay of the land that I've been describing. Cloud computing has maybe the majority of things can be moved up, but there's a bunch of things that go down. So, for example, moving an enterprise application like ERP into the cloud can be like a heart transplant. I heard the term, one CTO said that would be like a heart transplant. We can't attempt to move that. Specialized and optimized LOB, line of business applications in logistics and other business line of business apps, they can't necessarily be moved either. Where cloud computing is more expensive, and this is much of what we've been discussing, where you have a base load that's very stable, and you don't just have a need to move it. It's already working very well. You have a sunk cost, and your labor costs are going to be incurred regardless. You're not going to move it. Now, as for the cloud, there's a whole bunch of things. Commodity third-party applications, the SaaS items, are already way up there in use. Strategic advantage, perhaps a help desk. Perhaps you are serving offices nationwide or worldwide. The network advantages would be enhanced strategically with cloud computing. Computing tools may be easier if you're doing work using Ruby on Rails. There's some great infrastructure online. If you're doing Salesforce, obviously the force.com the ecosystem is very helpful. If you're doing work, maybe delivering an app, you can use remote apps. That is, Azure offers to remote your apps. So there's some wonderful cloud-only services that make things easier to use. Cloud computing, in many instances, may be cheaper, and so there's many things you can do up there. The little icons next to these items are which SEER tool you would be doing an estimate in to decide whether the decision for deployment should be in the cloud or in-house. CRIT plays a role in many instances, and CRSM as well. You can evaluate where things should go in the cloud or in-house. However, the ecosystem of, to use that term again, of cloud computing providers is extremely dynamic. And as we see here in the Gartner quadrants for 2012, 2013, 2014, it's constantly changing. Amazon themselves went through price reduction 42, or it might even be 43 at this point, 43 price reductions. So if I were to give you something about Amazon in these slides, and I will, it's probably dated within a few months. Although they are still the leader, but as we can see, Microsoft is really making tremendous progress catching up. And then we have everyone else, but everyone else has a place too, depending upon what sort of needs you have. There are the AWSs and Azures of the world, but there are also the Terramarks and CSCs that have their own things to offer. For the in-house analysis, however, we'll turn to CRIT. CRIT has a lot of things it accounts for. The data center hardware itself, real estate, power, bandwidth costs, energy, staff, depreciation, and even partitioning of applications within instances. These are all considerations in figuring out whether to put a data center in the cloud or maintain it in-house. CRIT helps you organize all of that junk. It's a complex analysis, and that's what the great reason for the framework is. The framework, as in this work breakdown structure, as you see, you can handle any level of scope required in the internal analysis. In this notional data center work breakdown structure, we have it broken down by infrastructure and user support. Within infrastructure, we can put in the servers, the storage, the network, facilities and energy required, and under user support, application support, and there's a whole bunch of other categories, depending upon what the needs of the data center or other sort of IT are. CRIT generally can handle it. Now we have a project. I have a project that I developed here to show what it's like to analyze a server center, data center versus providing in the cloud. A word first on labor costs. CRIT puts in a lot of labor costs in its estimates, and my reaction upon using it when I first started was, wow, there's a lot of labor. But the thing is that data centers maybe don't have a lot of labor that's direct. A large data center may have very low and non-linearly increasing staff for installation, operations, security, and facilities. But on the logical side, actually administering the virtual machines and servers, there are a very large number of engineers and admins, most of them working remotely. The number of servers that an admin can manage is lower for physical servers and an order of magnitude higher for virtual machines. For the average enterprise, for example, a typical admin can manage physical servers numbering in the tens, maybe 10 to 50. It depends upon the complexity of the applications that are on the servers. An admin can manage virtual machines numbering in the hundreds, maybe from 200 to 700. Again, depending upon a lot of factors, that's why the disparity is so great. The answer depends always on application complexity and system complexity for that matter. Facebook is said to be able to handle about 130 servers per admin. Microsoft indicates it can do 1,000 to 2,000 servers per admin. But the typical enterprise, Fortune 500 enterprise is not going to have as many admins, as many servers per admin as a Facebook or a Microsoft, which run what are called hyperscale data centers. They're at very high levels of efficiency. So the CRIT estimate does include a fair amount of labor, but it is very much in line with industry practices. That infrastructure work breakdown structure, this is what the estimate looks like. As you can see, we have a little build out in the beginning, September 2015. This is an estimate over about 5-6 years. And as we proceed forward, the first types of labor, the construction and the design, those things start to disappear, and we start to go into ongoing support. So the majority of the costs moving forward are actually going to be labor, although starting up, and this is only showing activity staff by month. At first, the hardware costs themselves are very significant, but we're not looking at it on this chart here. The pie chart gives another way of looking at this. Now we turn our attention to each of the elements. Servers, storage, these are the costs for each one of them. So material costs for servers in 2015 is really the installation of those servers, and then as we move forward, we have the support labor. Storage, which doesn't require as much direct management, has a very high initial material cost, and then relatively low supporting costs as we move forward. Networking, even smaller supporting costs with labor, significant initial investment in material. And this is for a data center that's about 900 servers altogether, 900 physical servers altogether. The great thing about doing a CRIT estimate is that the parameters are so flexible. I've been showing on the previous slides all the cost estimates for an infrastructure example for a data center, moderately sized data center. I haven't yet gone into the inputs into the analysis, but before I even do, I just want to point out one little feature of CRIT that lets you do really advanced analyses. The idea of global quantities. When you put in a number in CRIT, everything can be related to everything else. So it really speeds things up. Now, these are examples of some of the entries that are made into CRIT. The storage device replacement cost that I've estimated is about $6,500. Quantity of servers, between 400 and 800 servers. All this stuff gets factored in at various levels. Let's go back to the work breakdown structure that created the estimates that I showed you on the last few slides. For infrastructure only, basically I left out the user support at the end. We had a page that showed servers and storage, network, and facilities energy estimates. What's behind those entries there, those work breakdown structure elements? A detailed set of parameters are behind those elements that permits you to enter the number of users, number of applications you're going to be running, complexity, even for the application support element, which I show here, the daily support levels. So you can very, very finely model the operations in a data center, as we're doing, or in a wider IT scenario. Within those elements, those entries rather, we have some very interesting ways of handling them. For example, you don't want to go back. I'm going to go back a slide. You don't want to enter all these numbers over and over again. For example, let's say you got 22 users. You don't want to enter 22 everywhere. Or you don't want to enter the cost of the server everywhere, the number of applications. CRIT has a wonderful ability to let you set things globally. And not just set things globally, but set formulas. So let's say I entered the amount of critical storage I need in terabytes somewhere at 20, 40 terabytes, whatever. But certain aspects of my operation don't require that much. They require maybe a quarter of that. I can actually control those formulas. And so I can play with things. If I'm looking at a data center, let's say 1,000 servers large, but then I decide, oh, no, I only need half that, but I want to keep the same relationships. I just change my number of servers, and the rest of the estimate gets flowed through. So CRT is great. The takeaway from this slide is that I can set things up in CRT and then do trades that are really, really easy to make. because all the relationships are all based upon just a few entries. I can change the number of servers I expect, the number of applications, the number of users, all in one place, and everything else I've set up in CRIT will go and change and make the estimate completely new to reflect those trades. It's a really wonderful trade-off tool for IT estimates. Now let's go down again and look at some real numbers here. I just did a CRIT estimate for something that you see here, about 300 Windows servers and 600 Linux servers. So I did it in Amazon. Amazon has a wonderful, AWS, Amazon has a wonderful pricing page. I estimated the cost of developing that data center or those compute services on AWS versus developing a data center to handle identical compute services locally. And I put in about 900 servers, exactly 900 servers. I added a bunch of what are called volumes, that's storage, critical storage, which is high velocity storage, standard storage, and then archival magnetic storage. The estimate for the cloud is $296,000 a year. The estimate in-house is $5 million a year, $5 million. And this gives a great example of where the cloud probably handles things better. And, I didn't do a very, very, very careful estimate, so the numbers are not perfect. But the cloud is going to come out much less expensive than building up that data center from scratch. Even if there's maybe less expensive servers I could be using, or maybe I overestimated certain things, the takeaway here is the cloud is very, very viable. And so we've been saying throughout that the cloud is, that there's situations where it's useful. This is a great example of where you want to use the cloud. And even if the in-house estimate is lower, keep in mind that I can control those cloud instances. I say I need Windows servers and Linux servers numbering about 900. However, do I need them? Do I need them all day long? Do I need them every season? I can turn them on and I can shut them off. So my cloud estimate here is likely even lower than I provided for. I selected a 3-year upfront estimate for this, but if I had selected spot instances or on demand, or rather reserved, Amazon has a low backup computing capacity where they bring you instances when they're available at lesser cost. I could have actually made my cloud estimate lower. So there's a place for the cloud. Now, if I go back to the server example that we had, where we only wanted to replace one server, what does that look like? Here I've got a Windows server and a Linux server, and my estimate's $24.24, one-time payment, and $251 about a month. So factoring in all that, the cloud cost for 2 servers here comes to about $3,000 a year, and in-house about $14,000 a year. The cloud seems to be still less expensive, maybe not nearly as much less expensive when you're talking about single servers, but somewhat. Now, the nice thing about the CRIT estimate is that you can look at the details. This seems to be a less expensive option still for one server. However, if we look at the CRIT estimate, this one shows the cost by fiscal year, and it breaks out material costs and it breaks out labor costs. If I look carefully at that, material cost is only $8,873. That number that you see there, $8,873, that should look familiar. That's the cost of one server that we found much earlier in our webinar, that it cost us to replace our server. That was the number. The rest of the cost that you see is labor. And labor is essentially the admin and the other people who work on the machine and make sure it's working correctly, the database administrator, the security person. Those are costs that I'm largely going to incur regardless. So now, where the cloud was less expensive before, now when you take the labor costs out, the cloud is more expensive. And I could only figure that out by looking at the detailed IT estimate. Well, it made it more obvious to look at the detailed IT estimate, look at it with labor, without labor, compare the types of labor. I could do that in CRIT. I could add all sorts of different types of administration costs, do a much more complex analysis, and get at when labor is quote-unquote expendable in-house versus in the cloud, and when it's absolutely required either way, and get a much better feeling for the cloud costs versus the in-house costs. That's the end of the webinar. However, I really hope that you've gotten a bunch of takeaways from this, which is that cloud computing is subject to many factors. It's not just a simple migration. It has to do with how well you use your capacity. It has to do with the quality of the computing that you're seeking, whether it's high availability, highly networked, highly infrastructure-oriented computing, or whether it's something simpler. What your utilization is locally as well. Can you do a better job with what you've got? And also, what's the labor mix? What kind of labor can you do away with when you're moving to the cloud? What kind of labor do you still need? So there are a lot of factors behind cloud computing and renting or buying power washers. Thanks, everyone.